skill training video has been produced by SEMCA in collaboration with PSSC and CNK. This video is aligned to the job role Electrician Domestic Solutions PSS/Q6001, QP code PSS/N6002. We are now going to learn the step-by-step procedure for inspection and testing carried out by the electrician. Now we will see the type of inspection and testing to be done of house wiring that needs before energization of the circuit. Why is inspection and testing important? The fundamentals of inspection and testing are: first, inspect to make sure that everything is correct with the electrical installation, and secondly, test the electrical installation to make sure that it functions correctly. Is this a requirement? It is extremely important as inspection and testing are essential skills of any electrician. Qualification is the only proof of this ability. Inspection and testing are the operational parts of quality control. This is the most important factor for electrical network in generation, transmission, distribution, and commercial or household use. Difference between inspection, testing, and examining. 1. Testing. Generally, testing is the manual testing of the application to find flaws or defects in it. Electrical testing is done to find defects in the system and to fix them. 2. Inspection. It is a process of reviewing anything which is documented and which is used as a base to carry out testing. For example, patrolling at transmission lines. Inspection helps to find defects at an early age. 3. Examining. This is used to monitor the processes that are used in testing. For example, the different stages involved during testing. Inspection and testing. Inspection. We inspect the installation with regards to personal safety, equipment age, deterioration, and overload. The first part of a visual inspection is to ensure that the system is safe to test. Generally, a good place to start would be the power supply incomer panel. This will give a reasonable indication of the age, type, and size of the installation. Following are checklists for inspection of the power supply incomer panel. Things to look for at the supply intake before removal of any covers would be: 1. Type of power supply system. 2. What type of protection is there for circuits? 3. Is documentation available for the original installation? 4. Is the consumer's unit labeled correctly? 5. Is the earthing conductor in place? 6. Size of the earthing conductor. 7. Is the earthing conductor green or green and yellow? 8. Are all of the circuits in one consumer's unit, or are there 2 or 3 units that need combining? 9. Is there a residual current device, RCD? If so, has it a label attached? Is it a voltage or current operated type? 10. Do the enclosures meet required IP codes? 11. If alterations have been carried out, is there documentation available of test? 12. What size is the supply fuse or MCB? Is it large enough for the required load? 13. Are the seals broken on supply equipment? If they are, it could indicate that the system has been tampered with, since it was first installed, and perhaps a closer investigation is required. 14. Have any alterations or additions been made? 15. Would any alterations or additions affect the required disconnection time for the circuit concerned? Testing also needs to be carried out in a specific order before the installation can be switched on. If any part of the testing fails to comply with regulations, that test plus any other testing already carried out has to be repeated after the fault has been fixed. This is because the results of the tests may not be accurate and may have been influenced by the fault. In general, testing covers the following: 1. Installation resistance test between installation and earth. 2. Installation resistance test between wiring conductors. 3. Polarity test in house wiring. 4th. Earth continuity test of electrical installation. 5. Operational testing of residual current circuit breaker (RCCB). Now we will see the step-by-step process for inspection and testing. 1. First, we will check danger board label to be fixed on distribution board properly. 2. After opening the main door, single line diagram SLD to be fixed properly and wiring to be done according to SLD. 3. Distribution board body earthing should be properly fixed. As we are here seeing it was found in loose condition, now we are properly fixing it. 4. Now we will be opening distribution board cover and check protective device and wire connected properly. 5. Now you are seeing 3-phase power distribution in which incoming power supply came from 4-pole miniature current circuit breaker MCB and outgoing connected at residual current circuit breaker RCCB input terminal. From RCCB output terminal, power supply goes to different phase MCB. RCCB gives protection from imbalanced current flow. In that case, it breaks the circuit. We know that current flows through phase and return from neutral. By this way, it completes the circuit. This is called balanced system. If in any condition when current going through phase and some part will return to earth and remaining part return through neutral wire, this is called imbalanced system. In this condition, RCCB will break the circuit. For that reason, we use RCCB. It provides protection to human body as well as appliances. Here we will check RCCB and MCB are fixed properly. We have to ensure that wire connected DB and at the appliance, the end has proper ferrule and labeling. Here you are seeing all the wires fixed with proper ferrule and label. Labeling we do for proper marking or naming of wire. To ensure the labeling and tightness of all wires, all are in order. 6. We have to check insulation resistance of different wire between phase and between phases to earth. 7. We have to check the earth resistance. 8. We have to check the polarity test and be ensured that phase wire control through switch. 9. We have to do continuity test to ensure that correct wire from distribution board connected with the appliances. 10. Now we will check that RCCB working properly or not in fault condition. For that purpose, we are opening the cover plate of socket. Through test lamp in power on condition of socket, we are connecting neutral wire with earth wire and will see RCCB breaking the circuit or not. As we have seen after connection of socket neutral point with earth point, through test lamp RCCB break the circuit as light switch off, showing RCCB working properly. What do we do after inspection and testing? After proper inspection and testing, if any part of the testing fails to comply with regulations, that test plus any other testing already carried out has to be repeated after the fault has been fixed. This is because the results of the tests may not be accurate and may have been influenced by the fault. If after conducting the proper inspection and testing all results found in order, then we can start supply.